So students, here is the adder circuit. So we know the circuit of adder now. So what are the components required for this circuit? We need mu A741 op amp, one mu A741 IC, then 3 resistors, all are of range 10 kilo ohm each. Okay, then we need a DC power supply to provide plus 12 volts and minus 12 volts supply to the op amp. Okay, then we need a signal generator to provide the AC input signal. So here is the signal generator, and to observe the input and the output waveforms we need a CRO. So these are the components required to conduct an adder experiment, and I am using the spring board to conduct this experiment. So I have already connected the components on the spring board. You can observe here. So I have inserted this mu A741 IC to this socket. Okay, so to this socket the input terminals are these two. This represents pin number 2 and this represents pin number 3 and this represents pin number 6. Okay, and plus VCC is here, minus VCC is here, and this is the ground terminal. Okay, so from pin number 2 I have connected two input resistances of 10 kilo ohm each, and for one of the input resistor I have connected the AC input signal from the signal generator. You can observe here I have connected the AC input. So I have provided approximately 1 kilohertz frequency here. Okay, the input frequency is 1 kilohertz. You can set this to 1 kilohertz. Then amplitude is 2 volts peak to peak. See, this is the input signal. Input I have provided a sine wave. Okay, so it is pointing volt per division knob, it is pointing at 1 volt. So 1 into 2 divisions which becomes 2 volts. So 2 volt peak to peak input I have applied. Then one more input signal is the DC signal, that is 1 volt. Here in the power supply I have set this to 1 volt. Okay, so we can set the voltage using these two voltage knobs. Okay, whereas the current knob should be at the maximum position. Okay, so now I have set this to 1 volt and I am giving this 1 volt signal to one of the input to the resistor, another 10 kilo ohm resistor, and negative terminal I have connected to ground here. Okay, then so also from pin number 2 a feedback resistor should be connected. So a feedback resistance of 10 kilo ohm is connected to pin number 2. One end is connected to pin number 2 and another end to pin number 6 output. Okay, now then we need to provide plus VCC and minus VCC to the op amp. So here you can observe plus 12 volts is provided. Okay, plus 12 volts you need to connect here at plus VCC, and minus 12 is needed to be connected here. Okay, minus VCC. So minus 12, this take a crocodile clip and connect this to minus VCC. And here the ground, okay, the ground terminal should be connected to this green color knob. Okay, so this represents the ground terminal. And one more thing you need to remember here, this common ground terminal should be also shorted with the common ground which we made in the circuit. Okay, this ground should be also connected to the common ground terminal in the circuit. Okay, so now the circuit is ready. So the first input signal is sine wave of 2 volt peak to peak that you are observing here. So that signal I have given to the channel 1. Okay, now now you can observe the another input, that is the DC signal. Okay, see here now when I press ground, this is the 0 axis. Okay, now I will remove ground and you have to switch on the DC. Okay, you have to press this knob, okay, for DC signal. So from reference, the DC signal, it is shifted to 1 volt. Okay, so this is the DC signal given at the another given as another input. Now this the output you can observe at the second channel. Okay, so the second channel I have connected to pin number 6. Okay, so you can observe the output signal here. Okay, so this is the output signal. Okay, so here also you need to press the DC signal. Okay, so when I press ground, this is the reference axis, and the output signal after releasing the ground, it should be below the 0 axis. Okay, so you can observe here the waveforms. So this is the input waveform, okay, of 2 volt peak to peak which I have applied. Then this is the DC signal, 1 volt plus 1 volt DC signal. Okay, and what you are getting here is the output signal. You can observe here the output is shifted below the reference axis, below the 0 axis. So observe here the reference axis is here. So it is below, the waveform is below, and it is starting from minus 1 volt. So this is the output of the adder circuit. Next we will move to the next experiment. So here is the differentiator circuit. Okay. So this is the circuit diagram of the differentiator. So I have inserted the op amp here. You can, in this socket I have inserted. So for this socket, this is pin number 2 and this is pin number 3. Okay, so this is the inverting terminal of the op amp and this is the non-inverting terminal, and pin number 6 is here, which is the output of the output terminal of the op amp. And I have provided plus 12 volts supply from the power supply and minus 12 to this negative terminal. So here is plus VCC is provided with plus 12, minus 12 is provided to here minus VCC, and this ground terminal I have connected here. Okay, and this ground, take one more crocodile clip and short this ground with the common ground which we made in the circuit. Okay, so what are the components needed to be connected to the pin number 2? To the pin number 2 we need to connect 0.01 microfarad. So you can observe this is pin number 2. From pin number 2 I have connected 0.01 microfarad. Another two components, feedback components, are CF and RF. So these are the two feedback components, CF and RF, and other end of this should be connected to pin number 6. Okay, so to one end pin number 2, for the other end is the output terminal. Okay, so these are the connections, and pin number 3 here is directly grounded. Okay, now let us see the output of this differentiator circuit. So first we shall see square wave. Okay, I have given a frequency 1 kilohertz and square wave is given here, and amplitude in frequency is 1 kilohertz and square wave input is given in the signal generator. So you can observe a square wave here. Okay, so for channel 1 I have given the input signal, that is square wave. This is of approximately 2 volts peak to peak signal. Okay, so output is given to the another channel. So you can observe here the spike output is coming for the square wave. Okay, so for square wave you will get a spike waveform like this. Okay, you can measure the output also. So it is 1 division and it is approximately 1.8. Okay, peak to peak it is 1.8. So 1.8 into 2, that is the peak to peak amplitude of the output signal. Okay, so next now I will change it to sine. Okay, so now I have given sine wave as input. So for sine wave you can observe the cosine waveform here. Okay, so for sine wave we get the cosine waveform. So you can observe, you can tally both the input and the output waveforms. So this is the differentiator circuit. Next we will move to integrator circuit. So here is the circuit of the integrator. So it consists of an op-amp circuit here, op-amp IC. So I have inserted the op-amp IC here in this socket. For this socket, pin number 2 is here and pin number 3 is here and pin number 6 is here. So, and this is plus VCC, plus 12 volts I have connected here, and minus 12 also I have connected here, and ground I have connected to this pin, ground terminal. And one more crocodile clip you have to connect from ground to the common ground of the circuit terminal. Okay, so here you can observe from pin number 2, pin number 2 should be given with 15 kilo ohm resistance. So you can observe here this is 15 kilo ohm resistance connected to the pin number 2, from pin number 2, and this is the input I have given, okay, from the signal generator. And two more components CF and RF are connected here. So one end is pin number 2 connected to the pin number 2, and other end it should be shorted to the pin number 6. See, other end should be given to pin number 6. Okay, so now let us see the input and the output waveforms. So input frequency is 1 kilohertz and sine wave is given here. Okay, so sine wave is given as the input. So you can observe here the amplitude is more. You can set the amplitude. For channel 1 I have given a sine wave. The sine wave must be of 2 volt peak to peak. Okay, see here this voltage per division knob, it is pointing at 2 and this is 1 division. So 1 division into 2, 1 into 2 is 2. So 2 volt peak to peak input signal is given here, and here is the output. Output is given to the other channel from pin number 6 of the op-amp. So for sine we should get a cosine waveform. So you can observe here you are getting the cosine waveform here. Okay, see you can observe for sine wave, since it is starting from this point, you are getting the starting point from here. Okay, for sine you will get a cosine. Now I will change to square wave. So for square input, for square you can observe the triangular, inverted triangular wave. So this is a inverted triangular wave you are getting for the square wave input. Okay. So these are the three circuits. So today we saw how to conduct an experiment, how to set up an adder, differentiator and integrator circuit using op amp. So thank you students.